Hello and welcome everyone. We are just waiting for everyone to drop in to attend the webinar. So just a minute and we will start. Okay, I think we are I think we have most of the attendees in the webinar now, so let's start. Hi and welcome to all of you around the globe to this webinar where we will give you an update on where we are with this GravityVibe project. Hopefully some of you attended our webinar last year where we first showed this new solution to the market. And now 1 year has passed and we have been very busy with progressing the project, and which you will hear more about here today. And first some practicalities around the webinar. So if you for some reason the webinar window disappears, you can click the flower icon on your taskbar and you will come right back. We will use the Q&A function to post comments and questions, and we will have a Q&A part at the end of the webinar. We will have 2 polls during the webinar where you will be asked to send in your response. And we will also record this session to share it with you later. And then I would like to present us who are speaking today. My name is David Götwall and I am manager for the Customer Innovation Department here at MacGregor. And then we have...
My name is Mikael Hägglund. I'm sitting as sales manager for cranes and also for self-unloading.
Yes, and Mikael Jakobsson. I work with technical sales support for the self-unloader product line.
Yes, and a brief look at our agenda for today. So I will first have a welcome and introduction and a little recap of our work. Then we'll go through the concept, from concept to reality. And then about the testing and validation and the optimization and performance, and then the Q&A session at the end. So the webinar part is like 30 minutes, and then we'll have 50 minutes for questions and answers. But first, let's start with a quick look, just for you not 100% familiar with MacGregor as a company. MacGregor is a worldwide company with a vast product portfolio, as you see on this presentation. We sell, we design, produce, install, and service all sorts of ship equipment to a mix of ship types. So we have cargo ships, as you see in the top left corner, cranes, hatch cover solutions, container stowage, deck machinery, steering gear, and of course self-unloading systems. Then we have the RoRo part, and we are actually sitting at the RoRo headquarters in Gothenburg, Sweden, broadcasting this webinar. Then we have some Navy equipment, port solutions, a bit of offshore with the load handling, deck handling, and offshore loading, and also some renewable energy with offshore wind farms. We are around 2,000 employees in the company. We are present in 30 countries. We had a revenue of 769 million euros last year, and I already mentioned we are active in many segments and we are a worldwide company. So if looking at the world fleet, you will find MacGregor equipment on every other vessel. But now let's move on into the GravityVibe part and make a recap. So let's take a first look at where it started with all this. The challenge we faced is that we have certain materials that have a higher internal friction, and this creates bridging in the material, and basically it means that the material can't flow after a certain angle is reached. So if we look at the traditional gravity system, it requires cargo hold angles of 35 to 60 degrees, quite steep slope angles of the cargo hold. So this is really where the idea came, and how can we solve or improve this? How can we make the material flow below these angles? And this is where the idea with adding vibrations came from. If we introduce vibration, we will break the bridging and overcome the internal friction, and the material will be able to flow in a much lower angles, unlocking some significant benefits, such as the increased cargo flexibility. So by introducing vibrations, we can handle more challenging materials with higher internal friction. We can improve the operational efficiency, and in many cases also reduce the amount of equipment installed. So now I hope you are curious to learn more about how far we have come since the last time, because then we were just in the starting phase of building this full-scale test rig, which you see on this photo, and this is just a teaser for the rest of the presentation. But I can say for now that we have actually built this test rig, and my colleagues Mikael and Mikael will walk you through the testing and the results from it. So by that, I hand over to you, Mikael Jakobsson.
Yeah. So from concept to reality. So we start by looking at, we do a recap from the last webinar and look at what the layout is of a traditional self-unloader. So this is a part view of the traditional hold. You see that we have 2 rows of hopper with gates beneath them. And if we add cargo to one of the rows, we can illustrate some of the problems we have with the traditional setup. The first one is what David talked about. It's bridging, where the material is supported by the walls on each side, creating basically a bridge over the opening. You open the gate and this is all you get out. The second scenario we want to talk about is where you get a near vertical shaft from the gate opening up to the cargo. This is what in the business is known as rat holing. So what we find is that if we introduce vibration to the side panels, we can not only reduce the bridging, we can also eliminate rat holing. And the next thing we realize that if we add this vibration, we can even lower the hopper walls down to 15-20 degrees. And by doing that, we can essentially take away 1 row of hoppers and conveyors and essentially have the same volume. So this is what we drawn up, and this is what we actually built.
Yes, and if we go to the next slide, I think it's time to launch our first poll question for today. And I'll put it out on the screen now. And the question is, what is your biggest concern about this new system? Will it be the vibrations we're introducing? Will it be problems with the cargo flow or the performance or the maintenance of the system? So please go ahead and put your vote in the poll. See some answers coming in, and yeah, I think we have everyone. We will close, and interesting result. 100% of you are a bit worried about the cargo flow and the performance. So I hope going forward in the presentation we will be able to answer some of that concern.
Yes. Test and validation is the next, and we can say that we have made an R&D project for this GravityVibe system since a couple of years now. And if you're looking at this, let's say, matrix, you can see that we have been actually working with third parties, professional companies and institutes for having their professional input also to the design. And what has happened is actually that we, as a last step, we have built this test plant or test rig, which would be a perfect place for us to actually receive answers on the questions and the theories that we have worked with during the last years. So, and some findings we actually also can present here for you. And when it comes to the testing and validation, I think that for us internally, and I think also for the customers, it's a way of verify the, first of all, the material flow, if there are any issues in practice. And the second part is the vibration levels. Is there any impact on the vessel itself? And verified sound levels and impact on personnel. So this was some of the items that we wanted to have some answers on during the test phase. So a short video checking a little bit here. You can see the full flow gate in the test rig. And the conveyor belts. What can be said about this test rig is that it's built in size 1:1, so it's a full-scale test model. Here you can see the underside with the vibrator system and the steel bars, and also we have integrated a lot of sensors in the test rig so that we can have a lot of data coming out of the systems. So a control system also separately to the test rig. Of course, it's all the material that we have gathered is something that we can use also now in the future when we will build systems with this gravity system. Coming then into the system optimization and performance, and what we can say here is that we started up with around discussion of around 19 materials, and we ended up with 3 materials: coal, manufactured sand, and wood chips, which we made a theory together with tuners, a quite extensive analysis of that material specifically. So it was quite natural for us to, when we now have built this test rig, to start checking at least some of the materials that we have tested in the theory. The coal was a little bit difficult due to environmental issues. However, we have tested wood chips and fine sand. So coming to the first test result for the wood chips, as you can see here in the picture, we have made a test in 2 steps. The first step is opening the gate with the material, and then all the material that is free flowing is unloading onto the gate. And then at some point, the material which is left, here you can see it has created like a bridge. And as soon as we started the vibration system, all material started to move. And so it was clearly a success for this one, that we saw that there were the bridges and possible rat holes was actually destroyed with the GravityVibe system. For the next test that we made, we used the fine sand, and that has an angle of repose around 55 to 60 degrees. Also for this test, you can say that the all material was successfully unloaded. And just to make a comment in the picture as well is that it has been speeded up some part of the video, as you can see. But it was the most important is to show maybe that at some stage also this material created like a bridge. And then when we're starting here, the vibrators, once again, all material was flowing successfully. For this also, the material here, you can say, you can see also the final stage of the unloading, where actually all the material is unloaded. And the last test here was with gravel, and dimensions up to 10 millimeters. And here it's a material which is a little bit easier to handle, around 30 degrees. And the same result, material was successfully unloaded. And in all of those tests, you can say we had around 60 cubic meters that we have tested. So that was the amount of the material available. But here, the same tendency, creating some remaining material, which then with the vibrators was released. So from cargo flow perspective, we would say that we are very satisfied with the results. We see that the system is working. I will not change that. So some summary of the findings. As we mentioned a little bit about our worries at the beginning. When one of the things we looked at was, of course, the vibrations. This system gravity is isolated in versus the hull of the vessel. However, we would like to see the vibrations in the interfaces. And the theory from the Tuna report was confirmed. We saw that the vibration levels in the interfaces was clearly lower than theory and also the class requirements. Coming to the next part, which was sound levels. For this one in the theory, all the tests that was done was on clearly a level below 90 decibels. And 110 decibels was the critical level when you are working with manpower in this kind of harsh environments. In practice, we have not seen a problem with the sound, even close to the vibrators. Of course, there's a sound. However, we have not felt that it's a problem. And this is, of course, also something that we need to verify in the final end in the vessel. And the third part, cargo flow. We have, as I said, tested 2 of the 3 materials, and that was done successfully in practice. We did not see any big difference of the material flow if you compare the 15 degrees to the 20 degrees in those scenarios. And also that the new shape which we have invented in the bottom of the lower conveyor then gave no bridging and no rat holes. That was also a very good result. So we have also, for you to see a little bit about how the system could look like inside the vessel, I made an animation, and I will show you that right now. Here we have the conventional system, and this is the new interface with the MacGregor GravityVibe. And here you can see the system working, and we are opening one module at a time, and the material is now free flowing as the first stage. And then in the second stage, you can say then we actually quite short time we need to put in the vibrators, and then we also for that one we have this isolated metal in the bottom that vibrates on each module. And here you can see then the effect of that, maybe a little bit in the general mode, I would say. But what we can say here also is that we can actually prepare the material by vibrators while one gate is unloading. So, and now one thing is of course how to take this findings from the test rig and to how can we transfer it into a real operation and into a real vessel. First of all, as we have seen before in the previous webinar as well, that the system is a modular system, so it will have a quite easy part to assemble in the vessel. Next thing, when it comes to the cargo flow, we have an improved cargo flow because we have one transition point only in the vessel. So the material is going in one direction when it comes down to the conveyor in the bottom. So after the free flow phase, where you have one gate at a time open, the material could actually vibrate down in parallel in several holes before opening the gate for increased performance. And this creates actually that you can have a continuous flow of the material out through the vessel. So results, we see that we actually would be able to have a quite high capacity on the system, similar to traditional self-gravity systems. And some improvements that we see less risk for material, hookups or stops, and also the fact that you have a reduced time for cleaning up the holes manually. So that I think is the biggest things. And then of course also there are a lot of different parameters when you are looking at this kind of system, depending on you have what kind of vessel you are looking at, or and so on. And here you can see a little bit a matrix with maybe one of the parameters. You see improved cargo flow, increased flexibility, increased cargo capacity, and reduced investment. And depending on the size of the vessel and depending on which way to go, you can have different results. But as you see, for the small size vessels, you actually have an improvement in all areas, as we see it. For the medium size, if you choose for the one whole conveyor, then you have a partly increased cargo capacity, depending on the material flow properties. If the material is difficult, then definitely yes. For also the same would apply for the big size vessel, depending on one conveyor or two conveyor solution. And the key benefits, once again, we see that we have an increased cargo flexibility using the system. You can actually take up more different materials in the system. You can handle more difficult materials and receive added values for that. You have an improved operational efficiency since you have a good flow of the material and with less risks. And then, of course, also looking at the total operational lifetime of the vessel, you have reduced installation cost, and you have also operational benefits during the lifetime, which will be reduced cost in the final end. So that's a little bit shortly about the system itself.
Good, and now it's time to launch the second poll question in the webinar, and this is related to these key benefits we just mentioned. So now we would like to ask you, the audience, what you foresee as the biggest benefit with the GravityVibe system. So I will give you a couple of 10 seconds to answer this question. Okay, and now we'll close the poll and share the results. So we have the improved operational efficiency is the main one for the audience. So that's interesting to know. Thank you very much.
So, and
yeah, now the presentation is done, and we are moving into the questions and answers part. So feel free to post your questions. We have some questions coming in, and we will spend a few minutes answering your questions, and the ones we're not able to answer in this time, we will make sure you have an answer in written form of the webinar. But please post any questions. But let's start with this one then. How many vibrators do you use in both sections of your testing hopper?
I think we are using 8 per side at this stage. Practically in real life, it depends on the size of the ship, of course.
Yeah. And the second question, this one. How long or how many trips until the GravityVibe alternative pays for itself and starts saving money?
Yeah, that's a very interesting question. It's a very difficult question to answer. Yes. Depends on many factors. One, of course, is the distance between A and B, where you should do the logistic maneuver, and of course of the material, of the size of the vessel, and such. But we see that in most of the cases which we have done in the theoretical right now, we see that the life cycle cost is severely lower for the GravityVibe than if you come to other systems, with the traditional one. So it's difficult to say if it's pay of 1 year, 2 year, or
it depends.
Yeah, it depends.
Yeah. Okay, next one. Hi there, thanks for the presentation. Do you foresee any lining applied to the slope vibrating bulkheads, and in case should it be anti-wear rather than pro-sliding?
Yes, we don't see any benefits with adding a sort of low friction plastic lining to the walls. We are achieving the transportation anyway. And as for the high wear linings, I mean, such a small part of the material is actually sliding on the panels, so we don't see a benefit of that either.
Yes. Next question. What is the approximate maximum system capacity, say for example gravel handling in tons per hour?
I would say that it doesn't really come from the GravityVibe system itself, but more of the conveyors involved. But normally 5,000–6,000 tons per hour is quite reasonable.
Yeah. Okay, and then we have this question. Certainly there is a cubic advantage to conventional system. What about dead weight comparison?
It depends a lot on which cargo you're running.
Yeah.
I mean, if you're running a heavy cargo such as iron ore, you're sort of reaching the dead weight with almost any sort of hopper scenario. With light cargo such as coal or wood chips, volume is always an issue.
Yeah. That's where the advantage is in that case.
Yeah.
How do the vibrations work in practice? Are there permanent vibrations or are these more time-to-time impulses? And how will the vibration be controlled by the crew?
It's meant to be more or less automatic. I mean, we have this free flow period of the unloading where the material is running out by itself. And during that time, we're not running the vibrators at all. So it's only in the last part where you're sort of doing the angle from the free flow scenario down to the empty hoppers. That period is where we run the vibrators, and the amount of vibration and the length of the vibration is controlled by the control system.
Yeah. But for a whole unloading cycle, it's quite short time actually the vibrators are engaged.
Yeah, for each section it's about 10–15 minutes.
Yeah. Can the GravityVibe just be installed on new build vessels, or is there also a possibility for retrofitting to existing vessels?
I think there are no restrictions also for having that on retrofits or conversions, so it will be applicable for both. So that's the straight answer on that one.
Good. Okay, we have a comment again from the question about the dead weight. My dead weight question related to weight of the system compared to conventional. I missed the beginning. Will the webinar be posted? Yes, the webinar will be posted afterwards. But back to the dead weight question related to weight of the system compared to conventional.
We haven't done any sort of actual comparisons, but practically you have to have sort of less meters of hopper wall now that you have sort of this instead of this zigzag shape. Yep. So that will reduce the weight. You're taking away one row of gates, you're taking away one of the whole conveyors and two of the cross conveyors. Mm. So overall, I would say that the delivery weight is less, quite less. Mm.
Okay, and next question. In the videos from the test rig, it doesn't seem to be fully filled. Has this been tested?
Yes, it has been tested, but we have sort of been concentrating on the behavior after the free flow scenario.
Mm. Yeah. Because that's where the vibrators actually do the work.
That's the difference between the conventional system and this
one. Next question. I remember the idea was to have the test rig built with two different bottom angles, Has it been built like this, and has it been tested with these different angles?
Yes, it does. As mentioned, we have built the test rig based on an existing vessel design. However, we have in one side we have 15 degrees and the other side we have 20 degrees. So we have tested both angles with all the materials, and not so big difference in speed. Of course, the 20 degrees is a little bit faster, but if you're looking at the complete vessel design, including the support systems and so on, where you can actually take and vibrate down the material in parallel when you are preparing for the unloading, then we don't see that as a major issue actually.
Good. Okay. I think we have room for a few more questions. In the cargo hold, is there a gap between two panels?
Yes, there is, because they are moving individually. So there is a gap, but there is also a sort of a rubber sealing system to isolate them. So.
And the cover plate.
Yeah.
And then a question related to the cargo capacity. I think we have touched upon it a bit, but how much is the increased cargo capacity?
Well, we said it varies a little bit on what system and way you are doing this. We have seen, in the extreme cases with very small vessels with material high angular repose, then you can save more than 30% in volume. If you take with big vessels and uses a conventional laying up, then you probably will end up in 50% extra power. So, and everything in between.
Yes. I think we have one last question then. If we look at the scope of supply, what is the MacGregor supply in a ship with this GravityVibe system? Do you know that?
Yes. Normally we say that all supporting steel sort of is the manufacturer steel that's heavy is shipyard supply. So for the GravityVibe system in particular, it's the shipyard will usually do the support legs from the tank top up to the vibration panels, and MacGregor will supply the rest.
Okay, and we just received one more question here. Do I recall correctly that the resiliently mounted vibrating floor bears on the ship structure under full cargo head, then lifts after the gravity flow discharge phase when the loading is only 15 to 30 degrees angle of repose? Is that how it works? I don't know if we fully understand.
Yeah, I don't know really understand the question, but basically the support structure under the vibration panels sits on rubber mounts. And of course, those rubber mounts take the full cargo load into the ship structure.
Yeah, so I don't know if I fully understand. Yeah, okay, thanks. So message delivered. Good. Okay, I think that was the questions for today. So maybe we should thank everyone and wrap up.
Yes. If you have the last message and the final words from this, is that actually we see that the MacGregor GravityVibe self-unloading system, it increases your flexibility, it increases your efficiency, and also it decreases your operational cost. And if you think that this is interesting, of course, and you have a project or prospect, then please contact us and we will gladly assist you. And as we said also, we have a test rig. So if you have a specific material and so on you want to test, we have the possibility, unlike other.
Yes, that was all for us for this time. So thank you very much for joining our webinar, and welcome to the next one.
Yes.